Hello, everybody. This is John from Genus, and we're joined today by Dr. Jules Kajtar. And welcome, Jules. Thank you very much for joining us.
Thank you for having me.
Not at all. Why don't we start by you telling us a bit about yourself and what it is that you do?
Yes, so my name's Jules Kajtar. I'm a research fellow at the University of Tasmania. My work is in climate science, and primarily my area of study is on marine heat waves.
Great. So climate science sounds very topical and very important. Can you tell us a little bit about it?
Yes, so climate science is essentially all about understanding the Earth's atmospheric and oceanic processes and conditions and so on. So it's about trying to understand things like temperature, that's the one that people most readily think of, but also things like rainfall, winds, ocean currents, and all of those kinds of elements that make up what we know as the climate system. It's important to note that climate is not weather. So people sometimes confuse the two. So weather is really all about kind of the short-term processes, the day-to-day variations in things like, well, okay, it might be hot one day and cool the next. But climate is more about the kind of long-term changes. You know, what do we expect in a season, or what do we expect from year to year, and so on. So the kind of the way that I like to think about it is climate is what we expect, but weather is what we get.
Right.
And so it's important to study climate science because we know that the climate is changing. We know that it's due to human activities, and we need to understand how it's changing it and what impacts it may cause in future.
That sounds critical, actually. So you know that the climate is changing. Can you tell us how you know that?
Yes, so there are kind of three key pieces of information that I think really solidify our understanding that climate change is occurring. So firstly, we know that essentially from first principles of chemistry and physics that carbon dioxide, CO2, acts as a greenhouse gas. And this has been known for many, many years. A Swedish chemist by the name of Savant Arrhenius back in 1896 did some estimates of how much the planet might warm with the doubling of carbon dioxide in the atmosphere. So we know it from first principles. Secondly, we know it from paleoclimate studies. So we can, by taking past reconstructions of the climate system, what we call paleoclimate, we use proxies, things like ice cores, tree rings. We can reconstruct what the past climate may have looked like from these proxy records. And we know that when we look back over 800,000 years, nearly 1 million years in the Earth's history, we see that as carbon dioxide varies in the atmosphere, temperature co-varies with it, and also things like sea level. So that's quite strong evidence as well. But then thirdly, and this is the piece that kind of links it back to human influence, we know that carbon dioxide has increased over the past 150 years or so due to industrialization, increased human activity. We can directly measure the carbon dioxide in the atmosphere, and it's spiked up. And correspondingly, we've seen over that time, over around about the last 150 years, that the global temperature has increased by about 1 degree. And so we know those two things are very closely linked. And so I think those three things that really pin down for us that the climate is changing and humans are responsible for it.
That's interesting. And I know, as a planet, we're trying to limit, the increase in temperature to 1.5 degrees. It's kind of, I mean, do you think that's achievable?
I'm generally an optimist. I think it is, but it requires very rapid action. And yeah, it really requires decisive action over the next kind of 10 to 20 years. And, there's this other idea of kind of, well, we may overshoot in the short term. We might go beyond 1.5 degrees, but maybe with technological expansion, we can get it back to this kind of state in the longer term. Yeah, I think there's lots of open questions with that. Generally, I think the short answer is that I think it is possible. And, I think I do the work that I do because I'm kind of motivated about making some impact. So yes, I'm optimistic, but requires a lot of effort and a lot of discussions.
It does. It's interesting being an optimist and a scientist, where science being grounded in reality and empirical data. It's an interesting combination. So number one, I'm blown away that things like the link between CO2 and a warming climate through the greenhouse effect has been known for like 150 years. That's incredible. But what do you think? You've talked about industrialization, so we're talking about things like burning coal and fossil fuels. What is it that's really driving climate change?
Yeah, so there are kind of three key things here, again, in terms of human activities. So we burn fossil fuels to create energy. That's kind of one of the main sources of carbon dioxide and being released into the atmosphere. We clear land, so we know that trees are good kind of sinks for carbon dioxide. They draw down carbon dioxide and then re-emit oxygen. So as we're clearing more and more land for farming and so on, we're reducing one of these really effective carbon dioxide sinks. And then thirdly, another one is farming livestock. We're increasingly farming livestock. Coupled with clearing the land for the livestock themselves also emit CO2, and they're kind of the main things. There are obviously others that contribute, but they're kind of the main things that are linked to adding CO2 to the atmosphere.
And that animal agriculture is kind of like a double whammy, isn't it? Because you're taking down the forest that actually absorbs CO2, and you're building this whole industry, and then we know that cows are responsible for a lot of methane. And from what I understand, methane's something like 20 times more potent than CO2 as a greenhouse gas. Is that right?
It is, yes. I don't know the exact number, but certainly very, very much more potent than CO2. One of the good news aspects of that story, however, is that we know that methane is much more short-lived in the atmosphere than CO2. So it kind of can break down quicker or be reabsorbed much more quickly than CO2. But nevertheless, it is a concern. Increasingly with fracking as well. The process of drawing gas from the ground, that's a big source of methane. And if we really escalate our methane emissions, then that can have really catastrophic effects on the climate.
Of course. So when you talk about climate, what we know in the headlines of the media and things like that, what we think of as climate is the air around us and the atmosphere on land. But you specialize quite somewhere else, don't you?
Yeah. So my work is on marine heat waves, as I mentioned before. So marine heat waves. A lot of people will be familiar with the term heat waves. We have these heat waves where the temperature might be sometimes above 40 degrees for many days in a row. So like those heat waves over land, you can have them in the ocean, and these we term as marine heat waves. But because the ocean is a much more kind of slowly varying environment, the temperature varies on much kind of longer time scales. Marine heat waves, rather than hanging around for kind of a few days or so, they can persist for up to weeks or months. And where this can be a problem is for obviously the marine environment. So things like coral, kelp, fish, and all other aspects of the marine environment can really be affected by these kind of extreme temperatures that can occur in the ocean from time to time. And so
that it also helps the ice to melt quicker, right?
Yeah, absolutely. So yeah, you get a marine heat wave in a spot where you don't want it, near a kind of ice sheet or ice shelf. It can obviously melt that much more rapidly than in the normal conditions. So there are kind of two effects in a way. There's the slower underlying warming that's going on from year to year, decade to decade. That's what we know as global warming. So the atmosphere is warming, the ocean is warming. But then there are also these extremes. So as the temperature varies from year to year, you have these extremes, which we call marine heat waves. And then coupled with that kind of long-term warming, the marine heat waves are becoming longer, more intense, and more frequent.
Wow. And what causes them? Is it the same thing?
They can have different drivers. So this is probably a little bit more technical, but it's part of my work actually, understanding what drives marine heat waves, why they occur, where they do, when might they occur, and all these types of things. But kind of at a simple level, there are two basic drivers. One is changes in ocean currents. So, for example, if warm water is being transported away from the equator, where the ocean tends to be warmer, down to kind of more southern latitudes. So, for example, around Australia, we have the current along the east coast, known as the East Australian Current. Mm-hmm. A lot of warm water is transported along that coast towards the southeast of Australia. When that current becomes stronger, you have much larger warm water transport, and you can have marine heat waves occurring in regions like around Tasmania, so eastern Tasmania, or the Tasman Sea between Australia and New Zealand. So that's one of the areas that I study. Another driver, of course, can be things like high pressure systems. If you have a high pressure system sitting in the atmosphere, that tends to heat the ocean over a kind of prolonged period, and that can be another driver of these marine heat waves. So there's a bit going on there, but yeah. That's kind of my work.
Sounds like, especially with weather systems, extreme weather events being more common and, more extreme and all of that. Sounds like there's climate change that is created by humans has an effect in the sea as well then.
Absolutely, yeah. I mean, the most direct impact we have is on the atmosphere. The carbon dioxide emissions causing greenhouse gas warming causes the atmospheric temperature to rise. But that atmospheric temperature rise feeds back to ocean warming as well. It takes longer for the ocean to warm, again, because there are much slower processes going on. But we can see that at least the surface of the ocean is warmed. But over time, the deep ocean will be warming as well. And that's where problems can arise. When this warm water gets circulated to the very deep oceans, if it resurfaces near the poles where we have our ice caps and ice sheets, they melt, causing sea level rise, and all of this feeds back. So yes, our impact is not just on the atmosphere; it's really on the entire planet's climate system.
Yeah, it sounds like it. So what is it that we can do to slow this down or stop it, or or even reverse it?
Yeah, I think we all have a role to play. And I think this is where my kind of optimism comes in. I think that, as people are recognizing that this is an issue, I think more people are becoming more aware of what they might be able to do as well. Sometimes the story can seem like all doom and gloom, and if it's too difficult to solve, why do we bother doing anything? But I think any small action we can take really helps. We don't. I don't think we need to feel like the onus is really on all of us to stop our emissions straight away, stop driving, stop flying, stop eating meat, and all of these things. Although all of those things help, I think that our actions in other ways are important too. Having conversations with our leaders, making sure that we make that transition to green and renewable energy, but then also having conversations with our friends and family and teachers. Some people still have misconceptions about climate change and what it means, and so having simple conversations and changing minds really, I think, in the long run, can add to everybody's contribution to act on climate change.
That makes sense. Like we've all got a part to play.
Exactly.
We're all cogs in that complicated, massive system. But yeah, we can only control what we can do, right? And I think that's hopeful as well, because it's certainly from what we're trying to do at Genus. You see more and more action and frustration and all of these things that drive the positive change that we need. So I think grassroots is certainly critical. And I think, one of the things you touched on is talking to our leaders, spelling it out to the politicians that what's happening isn't good enough and it's not sustainable. Yeah, absolutely. Yeah. Well, Jules, it's been absolutely fascinating talking to you. I think I've learned a lot. I'm sure everyone that watches this video will as well. I'd like to thank you very much for your time.
Thank you very much for having me. It's been a pleasure to talk to you.
Yeah, thanks, Jules.